Alright, so today we're going to continue our study of Java GUIs utilizing JavaFX. What we're going to do, today we're going to talk a little bit more about event-driven, which we'll talk about how you interact with the mouse and the keyboard on, I will say, a lower level. And then afterwards, depending on how this course, how today goes, we'll either do a little example, maybe we'll program Tetris real quick. Haha, real quick. And afterwards, we'll probably start talking about what are panes and controls, what those actually mean, because those are actually tools to help you develop standard apps more quickly for application development. All right, so real quick recap. You remember with a JavaFX, you had to have an application. I'm sorry, your main class has to extend application and needs a start method, and that's where the GUI or the JavaFX portion of your code will begin. And this is where you can create different objects, or basically different objects, and possibly put them on the screen. This one is creating a circle, centering on 100, radius 50, stroke is black, white, the fill is white. And then we create a pane, a normal pane, which means that it's not going to manipulate any objects that you put into it. We put the circle into that pane, and then we add it to the scene, and then add the scene to the stage, and we're good to go. Of course, when we did it a little differently. We created two circles, different locations, just so when we run it, circle upper left, circle lower right. Any questions on this quick review? Just to get everyone back on the same page. Besides the colors don't match, I get it. All right. All right, before we go into more powerful features, we're going to examine FX's real-time, or maybe some people like to call them little low-level features. And these are very useful for games. I know some of y'all are doing a game for your project. That's very common, so which is good. Those are fun. So let's go over at least a little, or at least some of the FX real-time features. So some new objects we need to keep in mind. First off, you have a group, which is really just it literally just groups it together. It observes what it contains. So if you put something in a group, you can observe what's in that group or do something to what's in that group. You're just doing a grouping. Canvas is literally, think of like a paint canvas where you can draw objects. Excuse me. And then graphics contest. This performs basic drawing. This actually commits or does the draw. And then an image is what we use to represent an image. Well, it looks like we've already done that earlier. Okay, so let's see what this code's doing. Create a group, create a scene, set the scene, create a canvas of certain size. We're going to add that canvas to the group. Notice that the group is root. We're going to add the canvas to the root. We're going to find the graphical context of the canvas. Now notice we're getting the graphics context of the canvas. Now we can actually perform set operations on that canvas. We can fill it with red. We can set what the line stroke is to black, set what the line width is. We can create a new font, set the default font, and then go ahead and put some text on the screen. Yeah, we can even grab an image of the earth and put it on as well. Okay. Let's see if we can get this up and running. So GUIs, I'm going to call it Real-Time Basics 1, lack of a better name. Extends application. Go ahead and put application. What are you doing? There you go. Import the JavaFX application, and then we're going to need to implement the start method. All right. We'll go ahead and create a group root equals new group. Ooh. Make sure you import the correct one, the JavaFX scene group. Let's see how much of this I can remember. We create the scene, set the scene on the stage, create a canvas, add it. Okay. Scene, the scene equals new scene from the root. We're going to have to import the scene as well. And then we're going to, what happened next? I think it's primary stage dot set scene equal to the scene. So now we're putting a scene on the stage, and the scene contains a group. Here's where we want to create a canvas. Make sure you import the JavaFX canvas, not the AWT canvas. Just realized, is it hard to see back there? As always, a little bit. All right. Okay, what else are we doing? And then we add the canvas to the root children, then we get the graphical context from the canvas. Great. Bless you.
God bless your soul.
Indeed. Root.getChildren.add canvas. So we're adding the canvas to the group root. The root is part of the scene, and the scene is part of the stage. It can be hard to see how it's stacking down, but that's the way it is. We now need to get the graphical context. We'll just call it GC. Whoops.
I have a question.
Mm-hmm.
What exactly is the root get children add canvas here? What is that exact line of code do? Is it adding that, just that canvas we just created to the stage? Or is it adding to the group?
There it is. So what's this line of code doing?
Yes.
It's adding the canvas
The stage?
to the root. The root is a group, right? And the root is in that scene. And the scene is in the stage. I know it seems complicated. Indeed it does, but this is just the way you have to go about doing it. When you start doing a lot of advanced features, you really need to divide all these things out. That's why there's so many different steps. You think it'd be just nice and simple, make it happen, but unfortunately with GUIs there's a lot of things going on. Because the stage represents your window, the scene is what you're currently showing in that window, and then you wanted to create a group so you could add more than one object inside that scene, and so you can just add canvas to that group to put it on that scene. All right, down here we get the graphical context from the canvas. This allows us to do some low-level drawing. So we can do GC dot, we get all sorts of things. Let's see, we got set fill, set stroke, and set line width. All right, set fill, color dot, do we do red?
I like that one. It's like something that's on
You like which one?
the branch. Oh, down. Yeah.
Okay.
Yeah.
All right, we'll have to see what that is.
But it's beautiful.
Oh, you know what? Let's see, do we need anything else? Nope. We can just do the primary stage dot show. Let's just run it and see what that color is.
It's beautiful.
It's beautiful. I don't even, did it even do anything? I don't think it did anything. GC.set stroke. What do you want the stroke to be? Sure, why not?
Same.
What was the last one? Oh, set line width. Set line width. Keep it to 2. Then we have to create a font equals. Now how do we create fonts here? I never remember. Font.font. Oh boy. Oh. Okay. Font.font times New Roman. And then what else do we have? Font weight bold and 48. Sure. Font weight dot bold. And the extra, was that in there?
Yeah. Extreme.
It is. All right, we're doing that.
Also semi-bold if you're not wanting to be too bold.
Yeah. You just kind of want them to get this maybe a little more important, but not that important.
Right. Is that like taking it to 11?
Yeah.
Yeah. Yeah. Okay.
We're not going to a 20 yet. We're sticking
Is
right
Spinal
there.
Tap reference?
Yes. But this one goes to 11. It just divided it between 0 and 11.
Goes to 11.
But it goes to 11.
Oh, gotcha.
All right, so we can set the font, fill the text, and then okay, sure. Dot set font. Whoops, to the font, and then we go GC dot. Was it fill? I don't remember all these commands. Fill text. Hello world. And then we need to give it a position, don't we? Yep.
I'm excited.
You are? You can't wait?
Can't wait.
Let's see what it does. Oh my goodness. It does nothing!
Maybe that's the beauty of that color.
Yeah, you can't see anything. Let's see if we change it to black. I think I forgot to put something in the right location, and that's why it's coming up blank. Yeah, that's what I thought. So we have the group, the scene.
Change it back first, though. We gotta find out what that color is now.
Oh, okay. We have the canvas, we get the graphic canvas, we set the font, the line width. What are we missing? Oh, there's a stroke text?
Always.
Okay. What am I missing?
You don't want to be too aggressive with the text.
No, you don't. All right, we'll do the stroke.
It's not much of a caress, it's more of a stroke.
Right, right. We don't need to do the image yet. It just is not happening today. Let me make, oh, we don't have our main. Public static void main string args application dot launch. You know, I forgot what I'm supposed to type here. Wait, this one doesn't even have one. There it is. Launch args. That's what it is.
It's nice that we get to learn Ruby.
Yeah, in case you haven't noticed, I don't care about GUIs. Especially now. Right now, I really, really don't care about GUIs. They are not my friend at all right now.
It's this JavaFX, man.
Yeah, it's
It's different.
it's in the wrong way. All right, so get the group, add the root to the scene, add the scene to the stage, get the canvas, add the canvas to the root, get the graphics context. Yeah, what are we missing? Oh, do we never set the size of the canvas? Oh, that's hilarious. Oh, it's so beautiful.
I kind of like it.
You like it?
I like it.
Okay.
I think this should be the new font.
That should be our new font at all times?
Yeah.
Okay. All right, lastly, they talked about getting a Earth picture up there. In order for you to be able to load the image, I think we talked about it last time, it needs to be in the same, it needs to be in the SRC directory, if I recall correctly. Yes, it does, because that's where we have John Stamos. Good.
That's where we keep it.
That's where we keep them. We don't put them anywhere else. So I'm going to go over real quick and see if I can put them in there. Okay, there's John Stamos. Do we have an earth PNG? That's how it's spelled.
You are right.
What?
You are right.
It's spelled earth.
It shouldn't even need an E or an A. It should just be Earth.
It's spelled earth, but we pronounce it earth. All right, how do we create an image? I don't remember.
Why do we pronounce ear, but Earth?
Because English. So we'll create a new image from our earth.png. We'll import the amazing class. It needs to be an FX one. And then we need a gc.draw image. Draw the earth. Where should we put it? 180, 100. All right. And then when we hit go, oh, look at the earth. Oh, it's so
It's
pretty.
such a warm welcome.
Hello, world.
It's very alienish.
I want to be Africa.
Yeah. Come on, man. This is so messed up.
Yeah, we're just biased.
Yeah.
We obviously, we're America. Nothing else exists, right?
Yeah.
Center of the world, literally.
It's the center of the world.
In that picture.
It is. It's the whole world almost.
All right. Any questions about this one? See how I did a lot of searching and Googling? If you don't know the command for something, don't feel bad. Neither do I. Just look up what you Google, because it's ridiculous what's out there. Okay. So if we're trying to run a game, we're going to need something to keep track of time as it goes by. Obviously, as time goes by, we want to do something. So timers are basically a special object that run after a set amount of time. They're very useful for animating or timing how long something takes. You know, if you want, or what we're doing, Tetris, so we have blocks coming down the screen. Keep in mind that if there's an infinite loop in a timer, your program may freeze. So if you create a timer and then your code in the timer never exits, it keeps moving, you may freeze your program.
Just computer blows up, doesn't it?
No. You'll freeze the program. Modern operating systems are good enough nowadays to ignore your bad application, unless it's some type of security problem like a fork bomb, which are always fun. Do y'all know about those? It's where you have you have an application, and the first thing it does is clone itself. Actually, it enters a loop where it clones itself. So it's going to keep cloning itself. But the beauty of it is every time it clones itself, those clones are going to enter a loop of cloning itself.
So how fast does it take to?
It really, it's
quite
bad.
good.
It's amusing. Yeah, the whole thing real quickly just goes down to a crawl. It's amusing. And the scheduler goes crazy. Okay. Well, that was fun. Let's do something what are we doing this time?
Nanoseconds? Is that what that is?
Yeah, it looks like we're going to have the sun go around the earth. Cool. All right. Well, let's go over here. New Java class, earth, rotate around sun. Add it to get, extends the application, Alt-Enter, implement those methods, go back to real-time basics. Time to copy pasta a bunch of code because I don't want to type it again. Oh, okay, yeah, go ahead and import all that. Great. All right, we need the other images, so let's see if I can find them real quick. Sun.png. Hey, there it is. Whoa.
John Stamos is the sun.
All right, here's the sun.png. I hope that's the right one. Here, and then we need to locate space. Oh, it doesn't exist. That's because PNS doesn't make any sense. Let's see if it's in the same location. It is. Good. All right. So that put the space and image in the right place. Yeah, we got Earth, space, and sun. Beautiful. Fabulous. All right. So we have the earth. Let's create the sun.
Is that you teach the children how to say earth?
I really want to. I really want to do that, to make fun of the English language, because they will.
I think they would get made fun of
But-
more than the language.
You're
But-
saying it the wrong way.
I'm not going to do that to my children.
Yeah, good idea.
You could also teach them that addition is subtraction, subtraction is addition, but again, I'm not going to do that to my children.
See, I have my brother.
And then they would
my
come
brother
across a
say
kid
animals.
like me that would be like, you're doing it wrong.
You're
Like,
doing it wrong.
not bad.
All right, so up here the canvas was 512. Ooh, that's pretty huge. Let's go with that 512 instead of 5,000. And we aren't doing any of this silliness up here. And then what are we doing? We're entering a timer, if I recall correctly, right?
You have to draw the image for each one.
Yes. And it looks like what this code's doing after it creates the image, it gets the start nano timer. Okay. And then it creates an animation timer. Oh, that's pretty cool. All right. So final long start. What did it call this thing? Nano timer? Nano time equals. And this is where, was it system dot nano time? Perfect. Not the no time, the nano time. So that's the number of nanoseconds that have gone by. So the precision, actually the precision on modern machines usually does stick with nanoseconds. If you need something more than nanoseconds, I really want to know what you're trying to do, because that's pretty ridiculous, pretty crazy. All right, so then we want to actually create the timer, so we go action, was it action timer? No, animation timer. Animation timer. Let's go ahead and implement those methods. Bet you didn't know you could create a class inside of a function like this. No. So what this is doing is it's creating an animation timer and then writing the code for the animation timer class inside of here. Because animation timer is actually an interface, but we're going to just create one temporarily and actually implement the function that's inside of it, which is the handle. And then once that object is created, we're going to call .start on it and actually initialize it, or actually start it. And I never remember the calculations, so double T, blah, blah, blah. Okay. All right. Double T equals, was it now minus start nano time? So that's how much time has gone by. Divided by 1 million, which should give us milliseconds. Did I do that right? Yeah. All right. What do these two functions do? Double x equals 232 plus 128 times math dot cosine of t. What does cosine do? Wait, any of y'all in pre-cal? Calc 2. Yeah. So what does cosine do?
It gives you,
And usually your JSON over the file.
All right. What are the values that cosine gives you? Which one? 1 and -1. How about sine? Same thing. Are they in sync?
They're opposite.
They're opposites, yes. Ooh. Whoa. So really what this code is doing is, since it's cycling between -1 and 1, it's making the x basically go up and down, and then y go left and right. So it's, it's going up and down. It's basically making it do a circle by manipulating what x is doing. Yeah, like a clock.
Oh, that's crazy.
It's crazy.
That's insane.
Insane. All right, so we got x.
Lock you up, man.
So double the x coordinate, which will be 232 times 128. 128 would be the radius of our circle, times, what did we say, math.cosine of t. And then we need to do, oh, that was weird. Let's try that again. We'll do the same thing, but we'll use sine for y. And that'll give us where the Earth, or the earth, should be around the sun. Now we just have to draw the things. So gc.draw image. We're going to draw space first. It's 0, 0, right? Yeah.
plus not multiply.
Thank you. Yeah, because multiply gives you the radius, and then the 232 is the offset. Because you don't want it to be in the upper left, you want to move it down and right to some location. So space, 0, 0. That's actually going to fill in our background. It's going to overwrite everything we've seen beforehand with the space background. And then once we have that overwritten, we need to draw another image. What's it? The Earth, located on the x and y coordinates that we just computed. And then we want to draw image the sun. And where do we want this guy? 196? Sure, 196, 196. And then we're done. Let's see what that does. Should probably run Earth rotation. Whoa, that thing is moving fast. Whoa!
Is it changing direction?
That's insane.
It's moving so fast, it's really hard to see. We forgot to put a time somewhere.
That's awesome.
Let's see, where's the time?
Azure Space Travel was really like
Current nano time?
Do we need current nano time instead of just nano?
No, there was a place. Where do you set the time on this thing?
System dot time.
Oh,
I see a bunch of times.
we put the wrong calculation. 1, 2, 3. I'm gonna say.
It's very choppy.
Let's take off another 0. Maybe that'll smooth it out.
And a 0 makes a big difference.
0 does make a big. So this is correct, but something was annoying is it ran beautifully on my machine. And now it's running, how should we say, terribly. Wow. I'm missing something here. I've got to be. Earth. What am I missing? Clear the canvas. Handle. Start. I don't see it. Let's look up animation timer. Maybe there's something on here that'll tell us. Animation timer duration. Using the JavaFX animation timer. Who are these guys? Okay, sure. That sounds great. Blah, blah, blah. Okay, there we go. Timer, start. Do we have duration? Time?
I use it quite a bit.
They use the word time quite a lot. Single parameter is passed to handle. It contains the current time in nanoseconds. Alright. Why should we pass one value? It's right. Runtime goes to pause state while it's waiting to execute the next step. Sure. 2 methods, start and stop, to activate. Wow, this really doesn't tell me anything that I want to know. Alright.
They do a square root. I don't know if that matters.
Yeah.
They do a square root
Yeah. Radius.
in the code?
Yeah.
Oh, down here? Yeah, the problem is it's not updating very well. This is something different because we're not returning anything. So it needs to somehow know. Yeah, I wonder what's causing this. Now let's go and do a public static void main. Shouldn't mean anything, but we'll do it anyways. Launch args. Actually, we need application dot. Yeah, it's weird that it's going so slow. Huh. Because, what was it? If we removed a 0, it started going super fast?
It was new though.
And the more zeros you took off, it was like in hyper mode or something.
I swear it
So
looks
what-
like it's
so
changing
it-
direction.
Maybe if you get it so fast, it looks like it's not moving at all.
Yeah, that's what it looks like. I'm trying to figure out what's causing this.
Keep just deleting zeros until it goes.
Keep deleting zeros until it finally. Wait a minute.
So it just finally gives up. It's like, I'm done. You've done too much.
Yeah, I've got to be missing a variable here. T current. Time by start divided by. How many zeros is this? Oh. Oh. Got it.
Why does that matter?
Because then it's a double and not a long.
Ah.
Yeah, now it's going to run correctly. That's what the error was.
Oh, that's nice.
There we go. Oh, it's so much nicer. Yeah, don't forget your double there.
That Earth is really hot.
Why? Because it's so close to the sun?
Yeah.
How would we
We're missing Mercury.
How would we increase the distance from the sun?
Increase the radius.
All right, which number would we increase?
So instead of times 1 or plus 128. All right.
Okay, well, You mean like that?
Yeah.
Why was that not very confident?
It
There.
worked. I think. Yeah, it did.
Yeah, it did.
Oh, yeah.
Look at that Earth.
I'm learning.
So at least it's cooler. Now we need to rotate the Earth. How do we do that?
Rotate it.
I'm kidding. I'm kidding.
Oh, I mean, we can just make it spin upside
We
down.
can make it spin as it goes around. Yeah, that would be
It's
music.
kind of a 2D thing. Hard to spin.
That would be funny. All right. Any questions on this? Maybe you can start seeing how you can animate certain things inside of. Excuse me.
So the process for making that circle for that Earth move around the sun like that would be the same process for coding Tetris blocks falling.
Yes.
Oh, that's good. That's smart.
All right, keyboard input. Handled via setting a handler for key press and key releases. So you have to take care of it from there. Okay, that's a great explanation. All right. You know what? Let's stick with this Earth. I like this Earth object, Earth example. Let's see. Can we go over here and make a little private static? We'll say m radius. It doesn't like it because it needs to be an actual number. We'll make it a double. We'll go down here. Can we do m radius equals 128.0? And then can we replace this with m radius? Yeah, we can. All right. Okay. So let's just run this again just to show you I've just added a variable for what the radius is. All right. If we wanted to add a keyboard listener to it, those are added to the scene. Okay, great. The scene dot set on key pressed. New, what was it? Event handler. Yeah, event handler on the key event. Whoa, it automatically did everything for me. That's great. So if we have a key pressed, we're just going to do system.out.println. We'll do key press, and then I'll just do event.get, what is it? Get the code. And also, you can do basically the same thing for the scene.set on key released. New event. Sounds great. This time we'll do system.out.println key released plus event.get key code. Alright, so I'm just, when you press something, I'm going to print it out, and when you release, I'm going to tell you it's been released. So we have our little sun object going. If I were to hold down the, oh, see, it told me I pushed Alt. That's beautiful. If I hold up, key press up, and then when I let go, key released, down, press down, and then release down. But if I hold it down, notice it just says key press a lot of times, and then when you let go is when it's released. Do y'all know why that's happening?
Which part?
Hmm?
Why which part's that?
Is that expected behavior?
Yes,
Why is that expected?
because when you hold down a 0 key, it just gives you a bunch of zeros.
It keeps going with the zeros, right? And then, but if you push it real quick, it does up, down, left, right, so forth and so on. Okay. Any questions on this so far? I think we're about ready to change it up a little bit. So if event.get, let's see, key code equals key code dot up, then we'll have m radius plus equals 10. Oh, we need to increment this. Import the class. Perfect. Else if let's see, event.get code equals key code dot down, m radius minus equals 10. So what should happen when I hit up?
Radius
It gets farther from the sun.
The Earth gets farther from the sun. And then when I hit down,
The opposite.
the opposite. All right, let's see what happens.
Oh,
Oh, no.
that was almost really bad.
Oh, oh, the earth is taking a beating. Okay. Oh, wait, we're.
This is insane.
Can you take it all the way to the other side of the earth?
Can I do
The other
what?
side of the sun? Can you go through the sun?
Oh, he didn't go through it.
Oh, let's see if we can go through it. That's a good question. Oh! But now down is
So
bigger.
can we leave space?
Oh, yes.
Oh my gosh.
What happened?
Ah! Ah!
This is so great.
Oh, that was awesome. All right.
So I have a question.
Yes.
With the key handlers, like, so if you were doing something like you had somebody put in a formula or a equation and then you were computing the derivative or something, could you make it run off of the enter key?
Yes.
Okay.
And what you're thinking, there's a different way to program GUIs for that.
Okay.
And we'll get to that. Right now I'm doing more of a game development focus because I just chose to do that first. But we'll get to your more app level development in a bit.
All right.
But you could also, I mean, you could probably see how you could come up with a way to do that with this. All right, any other questions?
Want to play that all day?
I don't know. What do we get points for?
So what would you do if you wanted to take away the pause after while you're holding down the other key? You know, it goes and then it goes.
Oh, okay. I see what you're saying. All right, that is a great question. So there are different ways to go about it. The way I recommend doing it is you're actually going to have Boolean values to tell you if a key has been pressed. So, for example, let's go over here, and we would have, let me get rid of these unnecessary imports. So maybe we're up here, and we do private static Boolean m key up is pressed. And then just to initialize things, we'll say that right when we get down here equals false. And then if the key is up, then we'll do m key up is pressed equals true. And then on the other hand, where we at? We'd have to go down here, and then if event.getCode equals key code. As you can see, it's going to be a little more complicated. False. So basically what this is doing is it's setting a Boolean value to true when you've pressed it, and then back to false once you release it. And of course, if you press it after release, that means it went back down. So it's just a Boolean value to tell you when the key is down and when the key is up. All right. So now that that is happening, what you want to keep track of inside of your animation timer, and by the way, when you write a game, you're going to be doing something similar to this to keep track of ticks, because most of the time when you're gaming, you're going to, maybe you want to do things 30 frames a second or 60 frames a second or something inside of your logic. I mean, you could be rendering as fast as you want to, but your logic may want to only check every so often. So what we can do is we could have, let's see, long, last key check equals start nano time. And then what you want to do is, so that's the time in milliseconds from the last time. Now let's see what we got. So here, hold on. Okay. So here you go, if, let's see, last key check minus start, what are we doing? Minus start, hold on a second. We did that backwards. now, or minus last key check, divided by whatever this large number is greater than, we'll say 25.0 milliseconds. Now, we're saying every 25 milliseconds we want to check something. So we'll just do if m key up is pressed, then m radius plus equals 10. Let's see if I got that all correct. Whoa, it's super fast with the up. We'll do that with the down as well. How about that? That way it'll be really, really quick. Key down is pressed. And we'll have this. Key up is pressed. Key down is pressed. What do we got? I just realized a far superior way of doing this. But let's stick with this for now. Oh, well, that was easy. Key down is pressed false. And then we'll go up here. If key up is pressed. Oh, you know what we forgot to check is we forgot to update last key check. Key down is pressed. Then we'll subtract it. And what we forgot to do in this code was last key check equals now. You know, update it. Is access needs to be declared final or effectively final? What? That's not good. Okay. So what it's saying is that this variable needs to be part of the class itself. That's kind of confusing, but that's okay. We'll just put it in there. All right, see this, whoops, wrong side. You see now it's really responsive because it's not basing it off of that repeat that the OS does. Did that answer your question, Philip? All right. I know it's a little complicated. And I'll show you when we do Tetris an easier way to do this, if we do Tetris or whatever we're going to do. All right. Good question. Any others? All right. What else do I have? Tells you, or we already talked about, mouse inputs are handled similarly. All right, I'm just going to add the mouse animation, the handler here. You can do what you want with them. I think they're pretty intuitive. What was it? The scene.set on mouse clicked. In fact, I think we already did one, didn't we? We're trying to get your John. Oh, okay, yes, that's right. Mouse clicked on event.get x, comma, space, event.get y. Okay. So I can click my mouse all these different locations and it'll print out where it is. You can also have an event of the mouse moving, the mouse key press, the mouse release. Pretty much all the different mouse actions you want are going to be handled the same way. Hopefully you can see that the key listener and the mouse listener are very similar. All right. Any questions on this so far? What does... So this whole, the scene set on key released, which part of solid does it follow?
single responsibility.
That's always a solid first guess. True, and pretty much any good code will follow that no matter what, because you have to have objects. But what else besides the single responsibility principle? What is the single, actually let's stop. What's the single responsibility of the event handler?
Handling the event.
Hmm?
Handling the event.
Handling the event, you got it. That's all, does it do anything else? No, that's the one thing it does, so that's a nice single responsibility. How about this function set on key released? I mean, yes, it has one responsibility, but what else does it have? By the way, it's hard to see, but you can actually add more than one event handler here. So what did the open close principle? Who remembers that one?
This one, it allows you to extend your code but not change.
Right. So you can't change what the scene does behind the scene, behind the code,
But you can.
but you can modify it by setting up what the key released is. So it's open to modification, or open to extension, sorry. You can modify or extend its behavior. You can't modify its behavior. You can extend it to add your key release. I said that backwards. But you can't modify the scene. Okay. All right, what else do we need to talk about here? You can do a lot more game development at this link. All right. Let me go and stop right